Okay, this section's on what they call conditional statements. And the first thing the author does is define what a conditional statement is. Okay? And you're welcome to write on this handout as we go through it. You need to write on it. Okay? A conditional statement is a statement that can be written or turned into if-then form. Okay? And I know you've done a lot of if-then statements, especially in science class. It is true, a conditional statement is true in all cases except when the hypothesis is true and the conclusion is false. On a conditional statement, they're going to use, here's a new symbol, okay? And that symbol means implies. It's if P, then Q, or P implies Q, or you can write it P implies Q. But it's always, and when you set this table up, notice it's still the same way. It's still true, 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 false, false, true, and false, false. You always want to start it out in that order, okay? And then they're telling you it's true in all cases except when the hypothesis, and the hypothesis is the if part. Okay, so if the if part is true and the then part is false. So if the if part is true and the then part is false, it's true in all cases except that case. So with a different colored pen if you have it, this is true. This is the only one that would be false. And this is true, and this is true. Okay? And that's basically coming from that statement. It is true in all cases except when the hypothesis, that's the if part, is true and the conclusion is false. Okay. And they go ahead and define hypothesis. You've probably already gone through that in science class. The hypothesis of a statement is the if part. The conclusion of a statement is the then part. Okay? But when you see the arrow to the right, okay, it means if P then Q, or you can read it P implies Q. Okay? And this is the only one that's going to be false. All the rest of those are true. Okay, now, on the next part, we're actually going to write these and write it right below if you have a different colored pen. Okay, it says identify the hypothesis and the conclusion. Okay? The hypothesis is the if part. Okay? I would just do this. That is the hypothesis. I'd have you write just the H for right now, but I want you to learn how to spell that word. Okay? Some of you need practice on spelling. Then it is a hexagon, and that's the conclusion. Okay? Now, this next part, you have to be careful of the order. It says write it in if-then form. It still has to have the same meaning. It says an angle that measures 45 degrees is an acute angle. Okay? If an angle measures 45 degrees. Yep, that's the hypothesis. Then it is an acute angle. What they don't want you to do is don't rewrite it. Don't say if it is an acute angle, then it's 45. No, it's got to have the same meaning, same order. Okay? Okay? And this would be the hypothesis, and this would be the conclusion. Okay? So careful on the order when you write those. Okay, there's a new term, converse, and I'm guessing that's new to all of you. The converse of a statement is you interchange the hypothesis and the conclusion. The symbols, it looks like this. If we started out with P implies Q, you're going to just turn them around and say Q implies P. That's called the converse of a statement. We're going to go through on this one. If we did the converse of the statement up above, we would say if, go ahead and write it down, if it is an acute angle, then the angle measures 45 degrees. And that is the converse of our beginning statement. Okay, another new term is the inverse of a statement. Okay, the inverse, you negate both the hypothesis and the conclusion of the original conditional. This is our original back up here. You negate them both. Okay, so on the inverse, you're going to just say if an angle does not measure 45 degrees, no, yeah, that's right. If an angle does not measure 45 degrees, then you got to negate them both. It is not an acute angle. Okay. If an angle does not measure 45, so you go all the way back up to the original, and you're basically looking at this. You negate them both. Okay. And this original up here is actually, this is P implies Q. That was our original. Okay, then another new term is a contrapositive. The contrapositive is you negate both the hypothesis and the conclusion of the converse. So you go back up here to the converse. Okay, you look at this, you negate both those. Okay, so if it is not an acute angle, okay, then it is, or it does not measure 45 degrees. Who knew there'd be so much writing in math? Okay. Okay. Okay, now the author goes through a couple of things on to help you with the truth values as you're going through these. Okay, if you start out with the beginning statement, if your conditional is true, okay, when's the only time that conditional is not going to be true? When the if part's true and the then part's false. That's the only time when it's not going to be true. Okay, so go back down there. Hang on. There it is. Okay, if the conditional is true, then the contrapositive is always true. If the converse and the inverse are not necessarily true. If the conditional is false, then the contrapositive is false. Okay? When is the conditional false? Go back up. Look on your table up there. When's the conditional false? There's only one time. When the if is true and the then is false. Yep. The converse and the inverse are either both true or both false. You won't ever have a time where one of these is true and one's false. They are either both true or they're both false. Okay? And when they talk about logically equivalent, that means they have the same truth value, both true or both false. Okay, now let's look at an example. Okay, on the back page. It says write the converse, the inverse, the contrapositive of the following statement and determine if it's true or false. Okay, but I've actually written them and then we're going to go through true or false. Okay? Okay. All squares are rectangles. That's our beginning statement. Then you have to write it in if-then form. If the shape is a square, then it is a rectangle. Okay? If the shape is a square, then it is a rectangle. True or false? Are squares rectangles? That's true. Are all rectangles squares? No. But every square is a rectangle. Okay, so mark this true. Okay. The converse. If the shape is a rectangle, then it is a square. That's false. Whoops, false. Okay, now go back up above a little bit. Go back up above. The conditional and the inverse. Did it say anything up above about the conditional and the inverse? Not necessarily. Nope. Okay. If the shape is not a square, then it is not a rectangle. Could it be a rectangle? If it's not a square, could it be a rectangle? Yeah, so this whole thing is, if the shape is not a square, then it is not a rectangle. Could it be a rectangle? Yeah, so this whole thing is false. It could be a rectangle. Okay. Okay. Contrapositive. Go back up above there. If the conditional is false, then the contrapositive is false, right? Was the conditional false? No. If the conditional is true, the contrapositive is true. So these two go together. So this one is true. What else could we mark together over there? The converse and the contrapositive. Let's see. The converse and the inverse. We could put these two together, right? Yep, they're either both false or both true. Okay. Converse and contrapositive, is there any relationship between those? No. Okay. Okay, we're okay on that one? Look at number 4. Let's do this one. We're going to go through it together. If two angles are complementary, then the sum of their measures is 90. That is true. If two angles are complementary, the sum of their measures is 90. Okay? Okay, this is the P. That's the F part. And this is the Q. Okay, the converse. If you go up above, look at your statements up above. The converse, it's a lot easier if you just look at this. It's turn it around. Q implies P. So we want Q implies P. So if the sum of their measures, oh, sorry, I wrote that wrong. Gosh darn it. Turn around. Thanks. Yep, if the sum of their measures is 90, then the angles are complementary. Okay, then if you go back up to inverse, inverse says not P implies not Q. Okay, so now you have to negate P. You've got to negate this statement. So if two angles are not complementary, sorry, spelled it wrong. If two angles are not complementary, then the sum of their measures is not 90. Okay. Now the contrapositive. Contrapositive is not Q implies not P. Okay? So not Q would be if the sum of their measures is not, let me write that very good. If the sum of their measures is not 90, then the angles are not complementary. Okay, we said the first conditional was true. Now you got to go the reverse. On the converse, if the sum of their measures is 90, then the angles are complementary. True. That's also true. On the inverse, if two angles are not complementary, then the sum of their measures is not 90. That's true. On the contrapositive, if the sum of their measures is not 90, then the angles are not complementary. That's also true. Okay? So, on the homework, okay, in the directions, if it's true, then all I want you to say is true. You don't have to give a reason. If it's true, like on the true false, if it's true, just say true. If it's false, okay, you have to write a counter example. Okay? So that's like more than 1 point on those problems. If it's false, you've got to also write a counter example. Okay?